Hi everyone and welcome to Newegg TV. My name is Paul. Today I'm going to be doing an unboxing and some benchmarks on this hard drive from Western Digital. It's right in this brown box. It is the Western Digital Black 4TB. So this is an OEM hard drive, and if you're not familiar with OEM, that's original equipment manufacturer, and basically that means it's a bare drive, so it will ship in a box similar to this one with ample protection to keep the drive safe in shipping, and then you'll simply get a little baggie like this one. This is an anti-static bag, which you can open like this and pull that out, and there's the drive. So bear in mind, in order to connect this drive to your computer, you will need a serial ATA cable at least, as this drive does have a serial ATA revision 3 capable interface. That's 6 gigabits per second bandwidth, and you plug that in right there, of course, and then also the serial ATA power connector. Apart from connecting it to the computer, we also want to talk about some of the specs of this drive. So as you can see, WD Black, Western Digital has dropped the Caviar moniker, so they're just going WD Black. This is the top end of their client system drives. Specific model number is WD 4001 FAEX. It's a 4TB drive. When formatted in Windows, at least, you will get 3.63 usable 3.63 usable terabytes of storage. It's a 7,200 RPM drive, which means the platters inside spin at 7,200 revolutions per minute. It's a 3.5-inch form factor drive, so as you can see, like that, will fit into most standard 3.5-inch bays in your desktop computer. Let's see, what am I forgetting here? SATA revision 3, I already mentioned that. The throughput that Western Digital has rated this drive for is 154 megabytes per second. It's a 5-platter drive, and to do that, I'm actually going to give a quick visual aid for you guys. So here's a quick look at the internals of a hard drive. This is an already dead hard drive, and I must remind you folks, never ever open up a mechanical hard drive because you will kill the drive. But this can give us a look at some of the technology that's inside, as well as giving you guys a better point of reference for what I'm talking about here. So first off, platters. As you'll notice, the platters here, they spin around much like the records that we used to have back in the day. As it spins, you have a drive actuator assembly right there and a read-write head at the tip, and that's going to move out over the surface of the platters, and it's going to read and write data off of them. Now you'll notice here, if you look from the side, this particular drive has 2 platters right in there. Then you have this actuator and read-write head assembly. You'll notice that there's several of them sort of in a stack because they're going to be reading and writing data off of both sides of both of these platters. Now in our larger capacity drive over here, we actually have 5 of those platters, 800 gigs on each platter, and that gives you a total capacity of 4 terabytes. One other thing to mention is some technology that's been integrated into the WD Black series, and that is Western Digital's dual actuator technology. Basically, apart from the actuator here that you have, which is handling the movement across the platter and seeking to the specific tracks on the platter itself, you actually have an additional actuator that's a smaller one towards the end. That's going to allow the drive to zero in on the target track more quickly, gives a little bit more play on the end, and that can actually do smaller seeks without moving the entire assembly pack. So it's going to increase the throughput, it's going to reduce the seek times, and it's going to basically make it so you can get to the data without having to move this entire pack and actuator assembly across the surface of the drive. You also have the Western Digital technology that allows the read-write head to actually float above the surface of the platters without actually making contact, which is very important. Another important thing just about mechanical hard drives in general is the reason why you don't want to actually bump or jostle them while they're actually in use, because when they're not in use, the actuator and the read-write heads will park off to the side like that, off of the surface of the platters, and you want to make sure that you don't shock the drive. You want to make sure that you shut it down properly if you're going to move it at all, because if those actually make contact with the platters, it can cause damage, and you don't want that. But back to our WD Black 4TB drive here. I have a few more specs for you guys. It has a 64 megabyte buffer, which you can't see because it's on the other side of this PCB, but that's a DDR2 chip that's on there, providing you some additional storage for the drive, some fast storage that it can drop data onto before it actually writes it or reads it off of the platters on the drive itself. The average latency of this drive is going to be 4.2 milliseconds. Also for power draw, while it's actually in use and reading or writing, it's going to be 10.4 watts. At idle, it will draw 8.1 watts, and then if it goes into standby mode, it will draw 1.2 watts. It also comes with a 5-year warranty, which is one of the great features of the WD Black series, so they're definitely standing behind their drives. And I will mention that I really, really like Western Digital's RMA process because they make it really simple on their website if you ever do have to return a drive to them. Finally, the controller on the drive, it's a Marvell 88i9346 controller. Again, that's on the other side of this PCB right here. And I'm not going to disassemble this particular drive because I'm going to show you guys some benchmarks from it in just a moment. One final thing to note, you might notice that this is a 4 terabyte drive, not a 3 terabyte drive, and actually the Caviar Black series, the precursor to this one, went up to 2 terabytes. Western Digital skipped over the 3 terabyte capacity, jumped up to 4 terabytes, so if you're really looking for a ton of mass storage, this is a great drive to suit that purpose. Next up, I'm going to take a look at some benchmarks. So I'm just going to quickly run through some screen caps of the benchmarks I've run. First off, for the test bed, we're running an Asus Maximus 5 Gene motherboard. That's a Z77 chipset, Intel Core i5 3570K processor, and we're running 8 gigs of DDR3 2666 speed memory from G.Skill. Another thing to mention here is that I'm connecting to the native controller on the Z77 chipset, so we're at the SATA 6 gigabit per second interface. And then my first test is down here on the lower left. This is the Atto disk benchmark, running this at a Q depth of 4. As you can see, a bunch of different transfer sizes right there, and you can see the read and write columns, or write and read columns right there. These are listed here in actually kilobytes, but you can sort of easily divide by 1,000 to get megabytes. So we're hitting their advertised read and write speeds of about 153, 154 megabytes per second across the board, and I like to also point out that it jumps up to that speed very quickly as you get past the 5, 1, and 2 kilobyte transfer sizes all the way up to about an 8 megabyte transfer size. I also ran this at Q depth of 10, as native command queuing is one of the features of this drive. You can see that highlighted right up there. And down here we can see very similar results to the Q depth 4 test that I ran as well. We did manage to get 155 megabytes per second. And next up, we will run over to the Blackmagic Design disk speed test. Blackmagic does video equipment and hardware, and this is a disk speed test that they've put together so you can adequately look at the drives that you're using and see if they will work with the different types of video formats and compressions and levels of detail. You can see, once again, we hit very similar results, 148 megabytes per second on the read, on the write, 142.9 megabytes per second on the read. So this is going to be an adequate storage solution if you're going to be doing some lower levels of detail video. If you're going to be doing higher levels of detail in a video editing system, for example, you might consider a RAID configuration, of course. Next up, we're going to jump to Crystal Dismark. Let me just make that a little bit bigger for you guys. This is another popular hard drive and SSD benchmarking app. Again, similar results, 150 megabytes per second, 155 megabytes per second on the reads and writes respectively. You can also see the 512K, 4K, and 4K QDepth 32 tests. You can also see input-output operations per second listed down there on the bottom. So if you guys are interested in comparing, Crystal Dismark 3.0.2 is the test that I'm running here. It's a free-to-download application, so you can run that and compare a hard drive that you might have at home. By the way, this is all being run on Windows 7 64-bit, if I didn't already mention that. Next up, we have HD Tune Pro, which is a slightly older application, but more suited towards testing hard drives. This is actually the extra tests that you can run on the extra tests tab right there, but you can see the results for the various tests that are running, Random Seek, Butterfly Seek, Random Seek 64K and 8 megabyte sizes. Sequential, it actually will specifically read the outer, middle, and inner sectors of the, or actually portions of the platters, and give you the various transfer rates for those. And finally, burst rate is one of the tests that I do like to show with hard drives because it can show some really good performance. 338.341 megabytes per second for the burst test, which is very good performance for a mechanical hard drive. Next up, we have the standard benchmark for this utility, HD Tune Pro. We can see minimum, maximum, and average results right there. So minimum was 75.3, max was 147.6, average was 127.1. The access time is going to be scattered across the entire disk, so the average for that was 16.1 milliseconds, and again, burst rate of 351.6 megabytes per second. I believe, oh wait, no, I have one more. PC Mark 7 has a secondary storage test that you can run down there. So as you can see, the various results testing Windows Defender, importing pictures, video editing is sort of going through some synthetic standardized tests that sort of mimic some average computer usage. Overall storage score though, 2146, which is a very good score for a mechanical hard drive. And that wraps it up for the benchmarks. And that's going to wrap it up for this video, guys. Once again, this has been the Western Digital WD Black 4TB desktop hard drive. I'm Paul with Newegg TV, and if you enjoyed today's video, you can find more on our Newegg YouTube channel. Thanks a lot for watching, and we'll see you next time.